Assalamualaikum warahmatullahi wabarakatuh. My name is Amirah Binti Mohamad. My student ID is 2019230048. I am final year student from Faculty of Mechanical Engineering. My supervisor's name is Professor Technologist Dr. Aidah Binti Mohamad. Today I will present about my final year project 1, which is the title is Evaluation of Flexural Performance of Commingled Yarn, Aringapinata Glass and Basalt Isopropylic polyester composites under different exposure, seawater, distilled water, acid and alkaline. For my presentation, I will start with my project summary. In this project, there will be 3 fibers will be used, which are Aringapinata, basalt fiber and glass fiber. Therefore, in this project, this Aringapinata will be commingled with glass and basalt fiber to improve its mechanical performance and durability against various environment conditions. Then, isopropylic polyester, which is PE, polymer will be used as the matrix. The flexural properties of each composite will be measured according to a STM D790 at their normal condition and progressive time steps 30, 60, 90 and 120 days. And the durability of these composites will be defined based on their flexural performance. Next, I will continue with introduction and background of this project. For the introduction, I will continue with the literature review. The first is polyester matrix. It is a combination 2 or more materials that are mechanically bound together is known as a composite material. The matrix and the reinforcement are the 2 phases that make up composites in general. For example, natural fiber reinforced polyester, glass fiber reinforced polyester and carbon fiber reinforced polyester are the most well-known types of continuous fibers that are placed in a polyester matrix. The mechanical characteristic of a polyester composite reinforced with feather fiber and the outcomes demonstrate that the engineering applications can make use of the feather fiber. And lastly, the composite material made of 80% polyester and 20% feather has extremely exceptional qualities. Next, fiber reinforced polymer, or we call it as FRP. FRP, when it at high temperatures, has drawn a lot of interest from both academia and business. When FRP materials are warmed to a moderate temperature, they start to mollify and creep, which significantly reduces their strength and stiffness. And when the temperature at which the resin transforms from a glassy state to a rubbery state in FRP composite typically ranges from 65 to 100 degrees Celsius, 120 degrees Celsius. And the modular chains of the resin, its chemical bonds, and the bonds between the fibers all break when subjected to this range of high temperature, like the resin decomposition of the temperature. Next, I will continue with natural fiber, which is Aringapinata. It is from the sugar palm, is regarded as a waste product of the agricultural and cultural sector. Aringapinata will have a separation of the stalk from the core of the sugar palm fibers and remove the dirt from the core portion. The specific sections were soaked separately in water. An optical microscope model named Zeus was used to measure the fiber's diameter, and ASTM 750 compliant water absorption test was conducted to ascertain the fiber's hygrophobicity. There will have challenges and issues about the Aringapinata, including its traditional use, fully regulated sugar palm, low processing capacity, and limited market access. Next, I will continue with basalt fiber. It is an inorganic substance that is extruded from molten basalt rock, among other forms of fibers like steel, glass, polymeric, and carbon fibers. It shows a 6% drop in flexural strength after seawater immersion, and CF basalt or epoxy composite showed a 25% reduction. In understanding the relative mass loss and strength drop in the fiber's mechanical qualities when exposed to various alkaline or acidic components requires knowledge of the chemical properties of basalt fiber. In the research, that basalt fibers were more resistant to acid when submerged in HCl solution as opposed to being exposed to an alkaline environment an AOH solution. The last fiber in this project is glass fiber. Glass fiber is reinforced by epoxy. Composite was created and placed in salt water between 17 and 24 degrees Celsius for a 6-month bioactivity period. For example, hybrid biocomposite can be created by combining synthetic and natural fibers in a matrix or combining two natural fibers or biofibers in a matrix. For example, banana, glass fiber, and polyester are employed as the key element to create a natural fiber polymer composite. Next, I'll move to the problem statement. The first problem statement of this project is the cost of the Aringa pinnata is expensive to purchase, and the glass fiber is a synthetic fiber which is not environment friendly. Then the objective is to evaluate the flexural performance of commingled yarn Aringa pinnata glass and Aringa pinnata basalt isopropyl polyester composites. Next, to determine the effect of seawater, distilled water, acid and alkaline solutions immersion on flexural performance of commingled yarn Aringa pinnata glass and Aringa pinnata basalt isopropyl polyester composites. The lastly is to evaluate the effect of hybridization of Aringa pinnata fibers with glass and basalt fibers. For the scope and limitation, in this project, there will 3 different types of fiber will be used, which is Aringa pinnata, glass fiber, and basalt fiber. Therefore, this project will produce commingled yarn fibers from a combination Aringa pinnata and basalt fiber and Aringa pinnata and glass fiber. In this project, they will use PE polymer as the matrix commingle. The commingle composite will be immersed in different solutions, which is distilled water, acid and alkaline, and lastly is seawater. Next, I will proceed with methodology. First, we will have a selection of the fibers, which is Aringa pinnata, basalt, and glass fibers. Second, we will have a lab setup and preparation and research through journal that related to the project. Third, wash the Aringa pinnata using washing machine and dry using drying machine. Fourth, produce commingled yarn fiber from a combination of Aringa pinnata and basalt fiber, and Aringa pinnata and glass fiber using fiber roll machine. Methodology will continue with preparation process where commingled yarn fibers from a combination of Aringa pinnata and basalt fiber and Aringa pinnata and glass fiber were cut and prepared polyester as a matrix. Next, fabrication process where commingled yarn fibers from a combination of the commingled yarn samples will apply with polyester as a matrix to fabricate before testing. Next, fabricate samples were dipped in seawater, distilled water, hydrochloric acid, and sodium hydroxide for 30, 60, 90, and 120 days. Lastly, testing process where the samples were tested in flexure according to ASTM D790 to determine its mechanical properties. For the next part, I will continue with expected result. As you can see there were 3 figures, which is A, fiber rope machine that has been sketched in CATIA V5R20, and the figure B, drafting of fiber rope machine. C, the result of Aringa pinnata after cleaning up using washing machine. Aringa pinnata becomes more soft and easier to perform a commingled yarn with combination basalt and glass fiber. Next, D is a figure of woven of Aringa pinnata and E is woven of glass fiber. Next, table below shows the systems of commingled yarn, which is Aringa pinnata glass and Aringa pinnata basalt. Below shown example graphs that I take in a journal that a graph of composite specimens were submerged in water or chemical solutions for range 1 to 21 days at room temperature. The last part is I will continue with my Gantt chart. For the progress, I have done my part until wash the Aringa pinnata at the preparation section. that I have done the washing until the week 5, and now I'm proceed in produce the commingle yarn of the Aringa Pinatal and Basalt. Thank you.